In Unix we have the concept of a link. It's reasonably important that you understand what a link actually is, because A, they're extremely useful entities, and B, there aren't that many operating systems out there that actually support links. It's unlikely that you would have seen a link before if you're not familiar with Unix. So, how do we understand links? Well, I'll start by saying that in Unix it is possible for a given file to have more than one name, and the various names that a file has can be scattered around in various directories. What does that mean? Well, it means that if you've got a given file with some data in it, say the words "the quick brown fox," then that data file obviously has a name in some directory. Perhaps it's called file 1 in the dir1 directory. Well, please understand that it is possible that that same data could have another name. Say it could be called file 2 in the dir2 directory. So we can have two names, or two file names, in two totally different directories, and each is a reference to the same data. In other words, if you modify one and then go in by way of the other name, you'll find the data has modified there as well. If you don't believe me, allow me to demonstrate. There's a file in this directory called cat. Let's have a look at it. I'll just cat and see what I get. The quick brown fox jumps over the lazy dog. Okay, now I'm going to go into subdir1, and there is a file in here called fish. And if I cat fish, I find out that it contains exactly the same information. But is it the same file? It contains information, but it could just be a duplicate of the original file called cat. Okay, well, I will now go in and modify fish using vi. And I will add another line. This is another line. Okay, and I'll save the file and quit. Then I'll cd up into the parent directory where I will find the cat file, and I will now display the contents of the cat file. You can see very clearly that what I entered into the file called fish is now displayed in the file called cat as well. In fact, they are the same file. They just have two different names. Okay, I guess that's a reasonable enough proof that it's possible. Each of these names is called a link. We can say that that particular file has two links. Each link shares the same data. Each link also shares the same inode. So there's only one inode. There's one set of data, in other words there's one block, and there's also one inode. That obviously means that each file, each link to the file, if you like, shares the same permissions. If you change the permissions on one, you're changing the permissions on the other one. If I choose to make one of them read-only, the other one becomes read-only as well. I can't change one independently of the other. Now, I want you to understand that as far as links are concerned, there is no original and there's no copy. Certainly we can create another link to an existing file, but once we have created the second link, and there are two links to the file, neither of them is considered to be the original. We're making the other one the duplicate or the extra link or something like that. They're both considered perfectly equal in all regards. This might seem a little odd, especially if you have a file and you create a second link to that file, and then you delete the original link. The second version that you created simply continues existing without any problem around the fact that the first has been deleted. Now, I can't stress that strongly enough. Just about everybody, when they first encounter the notion of a link, believes that somehow the original is more important than all the duplicates. But I assure you that's not the case. Now, that is the case when we talk about symbolic links, but we don't know what they are yet, and we're going to learn about them later. Anyway, let's see how we go about creating and displaying links. Before we do that, it's very important to understand that when you're using the RM program, remember you think of the RM program as the program that deletes files? If you are deleting a file and there are multiple links to that file, and you try and delete one of the links, all that will happen is that name that reference to the file will be deleted, and all other references to the file, all other links, will remain intact. In other words, the file is still there. You just can't access it from where you were accessing it before because you've removed one of the references to it. So it's quite possible to delete a file and find that you get no extra disk space as a result, simply because there are other links to the file. So what happens is, when all of the links to a file have been unlinked, or deleted if you like, at that point the data is then deleted. And the way Unix deletes a file is the way most other operating systems delete a file. They simply mark that space, they mark that block as being now available for other files to use if necessary. So the implication of all of that is that any old file is simply a file that contains one link. If you create a file somehow, perhaps using Vi, it will simply be a file that contains one link. You can create as many links as you like to that original data, and even delete the original link or the original reference or the original name to that data, and the data will still be intact. We shall create some links in the next module, but before we do, I'll show you how you can examine how many links there are to any given file that you find. You can just use ls-l. We've been using ls-l now for almost the whole course, and it's been telling us how many links there are to each file that we see. We just haven't been paying attention.